Okay, very good evening. It's Vikram Sareen, Chief Architect, Mula Technologies. What we're gonna do today is we're gonna actually do the local stress test. When I say local, means that the stress test is actually executed on the same machine. So which it means is that there is no latency introduced in terms of network. Everything is being stress tested on the same machine with Axiom is deployed with the JMeter tool. So this is the kind of load we're going to look into from 150 all the way to 1000 concurrent users will be coming in. Sorry, that's a mistake I've made here. Let me correct it. And then in parallel what will happen is that we're going to test 3 APIs and they're going to get tested, and then we're going to look at all the system statistics that's going to go on. So with further ado, let me quickly get started. So it's running over here. So I'm just going to quickly come and check if I've set it to 150. Sorry, it should not be, yeah, it's supposed to be 1/3 of that. So that means that as per my Excel, it should be 50 each. So the total load will be coming out is 150. Yeah, so let's get started. Yeah, the stress test has started. So let me quickly look at the, sorry, oh sorry, I shouldn't be here, I should be over here looking at the browser. Okay, just quickly giving me, so the CPU has gone up to be 9, maximum is 9, 13, 13.5. The maximum file opened is almost 450. Yeah, so 9 and 450 is what we are looking at, and I think the stress test has ended. So let's quickly look at, sorry, yeah, so let me quickly fill up the Excel. So number of threads were 450 and the CPU utilization was 9%, and then we have no errors, and throughput was very nice. That was on average, the throughput was I would say 125 if I have to take it like that. So this error was 0. Okay, so this we'll take it as throughput, which is 125 per second. Yeah, and the response time, if you look at the response time, on average has been extremely well. So it's 0.2 seconds. So it's very good. 0.215 seconds. Yeah. Okay, now let's move to the next one where I'll be putting 100 each. So let's quickly open the file and change it to 100. So it's 100 each, meaning all the 3 APIs done parallelly. So meaning that we're going to get a load of 300. So I've started the test. Let me monitor the load. So it's already gone to 16 with 130. So almost 600. So it's 359. So maximum CPU test was 16. So yeah, performance wise we are looking quite okay. So it's almost 350 threads only. Yeah, so I think, yeah, on average the CPU is around, maximum was 16. So yeah, 16 is the maximum. It's being over there for a while. Yeah, I think looks like it's executed. Yeah. Okay, so 3 CPU was 16%. Then the maximum threads apparently were not many, which is funny. Now let's look at the throughput and also the errors. Okay, so the throughput on average I've got is around 240. I would say let's keep it as 242, and then as you would see there are no errors which are being recorded, and the average speed that I have got is 0.4. So the average which I have got is 0.4 with 243 and 0 errors. So 0 errors, 0.4 seconds, 16, 340, and throughput is 143 per second. Not bad performance at all. So let's push it to the next level where I'll giving it as 133, or I think let's go with 500 straight away. I'm going to take out this test case. Let's go with 500, that is 167. So per API I'm going to bombard it with 167 threads. That means parallel concurrent connections coming in. So okay, now let's get started. Okay, so let's look at the okay, 420, yeah, okay, processor 14, 435, processors nearly not loaded much, 430, 14, 15, yeah. So it's on average, it's almost looks like the same performance which is coming for 300. So memory wise also we are doing quite okay. No worries over here, it's not dropping drastically. Okay, number of files are also quite okay. So again 15-16% was the maximum, and only the number of threads which are parallelly being worked upon has gone up. Okay, so let's look at 16. Yeah, that was the maximum. I think 440 was the maximum threads. Yeah, I think it's going on for a while. Yeah, but the good thing is that yeah, okay, the stress test has ended, and the maximum threads which we saw was around 440. Again, no errors, and the CPU was around 16% again. So let's look at this again. So over here, the average which I have got is 244 for 25,000 requests which was sent. There was no error, and then the average mean time is 0.675. So the average time I've got is 0.675, 0 error, 16%, and the throughput is again almost the same. So 300 and 500 have actually led to the almost same, except the performance of the speed has been a little bit degraded by 0.2 seconds, 275 seconds. Now I'm going to jump into the 700. That means I will be giving 233 load. Okay, I'm going into the file. So 233 is what I'm going to give as the load. Okay, let's get started. Nope, sorry. Okay, so again still no errors. And now let me look at the processor. Okay, 570, 14%, CPU 16.6. So okay, 570 number of threads on average. Yeah, so I think that's the maximum which processor is taking. So again it's almost 17%, not much different. Threads have been gone up quite high actually. It went up to 580. And then let's look at the other parts which are going to come in now. Yeah, so let's look at, okay, looks good because there are no errors as such, and the performance is also steady for 240 to 240, 238. So I think on average it's giving us 240. And as you would see is that already 14,000 requests have been entertained. So it's going quite steady actually. Yeah, so it's 21,000. So it's, yeah, still no errors, which is great. So if you look over this column, there is no error over here. And the average time which I'm getting has gone up a bit. It's actually become 0.95. Yeah, so but what is beautiful is that the speed is still less than a second response time for all of them, for a load of 700 requests or concurrent users coming and bombarding, and there has been no errors reported till now. So without network latency, if you look at the pure performance of Axiom Protect, it's doing quite well. Yeah, okay, so we have the summary here. 443 is my average, then 0 errors, and the total average time is 0.94. So again, not bad. So 0 errors, 0.94 seconds is what it has taken in terms of average response. And we also have the throughput as, I think if I'm not wrong, it's about 243. Okay, so not bad. 243 is almost the same. So throughput is constant. Now I think we'll go for 900, and then let's do the last one, which will be 1100. Yeah, so let's be a little bit more ambitious. So now I'll be putting 300 into the file, into this stress test file, and so the collective load which I'm putting will be 900 concurrent users or concurrent threads being pushing the system. Yeah, okay, so let's get started. We should hope to see some drops, but again it doesn't look like the system is loaded a lot, so it's doing quite okay. So let's look at the processor. So 7%, almost threads has gone up to 710, 16% CPU, 14% CPU, so 20% CPU. Okay, so that's where it kind of went to that 20 figure. Okay, so 710 and 20 is what we are looking at. Yeah, so 20 and 710. Yeah, so that's what I think is the peak that has gone in. So let's look at 710 and 20% going in. So let's look at the other aspects which are coming in. Oh, it's fantastic. We haven't seen any error till now. It doesn't look like it will give any errors. And then you can also see that the average throughput is also there. However, what we see is that the time has increased, so it's to 1.26 seconds which it is going for. So meaning there is slowness, but please do remember the load is 900, so it's really not I would say, sorry about that, yeah, okay, it's not really pushed to the extreme level. So if you really see, it's doing quite okay. Okay, 730, 727, yeah, okay, this is heavy load, but the good thing is the system is able to really pump it up and push it to the next level. Yeah, okay, so I think we should see the end towards it. Okay, it's, yeah, amazing. There's still no error, being reported, so it's doing quite well. So I just want to show you that if you are looking at some kind of performance, then it would have actually given something like this. So sadly we are doing it on a Windows server, sorry, on a Linux server, so it's the data is generated but it's not being made available, so it's not looking that great in terms of UI. Otherwise in Windows it looks like this. So let's check if the stress test is finished. Yeah, okay, fantastic. So 45,000 requests have gone in. Again 241, not bad in terms of average throughput. Then the time is almost 1.23 seconds and amazingly no error. So the average response time is 1.23 seconds and the throughput is again almost the same and no errors. So fantastic stuff done here. So I'm pushing it to a little bit more higher, where we'll go for 400 now. Okay, so let's go for 400 per API. I think the pattern is where we are looking at drop in terms of performance, that means response time, and that's the only factor which is coming in over here. Okay, let me just reduce the time a bit so we can do it faster. So I think I'll just give it to 25, or let's say make it 30 loops going in. Okay, so clear. Okay, starting now. Sorry, what I see now is essentially going to be that what's the load I'm looking at. Okay, it's almost 900. CPU is still 16. So it's almost 900 threads being created. CPU looks quite okay. It's not loading too much. It's 900 plus threads now. Entertained. Yeah, so CPU looks fine. Okay, the total number of files are basically the connections which are being made internally. So that's also crucial, because if it exceeds too much, then sometimes the connection timeout can also come in because of that reason. Okay, so 915. CPU still looks quite okay. So the maximum we have touched upon is I think 18 in this case. Okay, so performance wise we are again quite okay. No errors reported till now, which is quite nice. And let's see if again the throughput is also not bad over here. And then yeah, the average time has again gone up, so it's 1.6. Okay, let's look at the CPU and the threads. Yeah, so I think 910 was the maximum. The CPU again, it's 17-18%. Oh, 29, yeah, so CPU touched 29. Okay, we haven't really stretched this too much yet. So let's go to the breaking point. Okay, I think it looks like it should end now. Yeah, so okay, so if you look at it, it's 400 per API, 1200 in total, and yeah, that's where it ends. So again, not bad, 0 errors, we don't have any errors here. And then we have the average, so that means let's quickly fill our sheet. So we have throughput of 235, 910 were the threads that had gone in, and then no errors, great, and then 29% was the maximum. So the average time taken over here is almost 1.664. So 1.664, so that means 1.6, I would say 7 second is what I will take. Okay, now let's push it to another level. So what we'll do is that we'll go for 600 each. So that will kind of sum it up. Oops. Okay, so yeah, 600 each, and let's see how it goes now. So we will be looking at a stress of 1800 concurrent requests coming and hitting the server. Okay, so let me quickly modify the file. So now we are going for 600 each, right? Yeah, 1 second, let's check. Yeah, 600 each is what we're gonna go for, and I think I'll just keep it short, 20 loops. Okay, so let's run it again. Okay, now I should see some, yeah, okay, 100 and almost. Okay, the CPU is also initial CPU were created more number of threads, but now it's almost 1300. Excuse me. Okay. Yeah, CPU again, it is 24% is the maximum. Again, I think I'm confident that we will not get any errors because system looks quite okay. Let's check. Yeah, no errors, but performance is throughput has dropped a bit. Excuse me, I'm a bit under the weather. Okay, performance is not that bad at all because no errors. So an average time is also about 3 seconds. Yeah, throughput has dropped surely. Yeah, so it's been quite okay actually. 32% CPU gone. Okay, yeah, here it ends. So the maximum number of threads we saw was around 1300, and then the CPU was also around 24%, and then the average time actually has increased to 2.98 seconds, but amazingly zero errors. Yeah, and the throughput we have to see, and the throughput has yeah, definitely it has dropped. So now it's about 198.5 per second. Yeah, again done locally. Okay, what I'm going to do is I'm going to push it to another level, which will be 1000 each. So that will be pushing it to a level where we can really see if the system collapses and starts giving errors. One of the tweaking we did was we actually increased the number of open files or files that can be opened. So that kind of gave us a good improvement in the performance. We didn't expect that, but somehow that is one of the reasons where the performance will be this thing. So okay, let me get started now. So we are running the test for 1000 each on the each API, each servlet hitting it, 1000 concurrent users. So now we're gonna have a huge, I would say, increase in terms of resource usage. Okay, the number of threads has already gone to 2000 something. Yeah, so wow, that's fantastic. The CPU is still not used much, so it is used, but it's not giving you too much of this thing. So yeah, the number of files which I've opened has gone more, but it's just no real impact in terms of the actual operations. Yeah, so it's almost 2100. Yeah, so we're quite surprised with the performance. So let's look at it over here. Okay, the throughput has certainly dropped. Throughput has certainly dropped over here. Still no errors, but the average time has really gone up now. It's 11 seconds. Yeah, I think that's the kind of unacceptable time we are looking at. But again, the beauty is there are no errors. So the system is doing quite okay. The throughput is definitely down. The average time, yeah, I think average time is around 8 seconds, 8 or 9 seconds. So now we're gonna do is we're gonna push for 2000 threads per API. So that means in total we'll have 6000. So yeah, so 2100 threads being created on the server side. Again no errors, so that's good. Sometimes network latency can also introduce errors, and that is what was happening yesterday when we did the stress test over the internet, over the VPN. So even for lesser load, the system was not able to take that much amount of connections, and then the connections were timing out. So without any latency in the system is doing quite well. There are no errors and no timeouts that are happening. So yeah, but performance obviously it's much slower. Much slower. If you really look at it, it's much slower. So average time is quite unacceptable now in terms of production setup or production rollout. Yeah, so that should hit to the end, and if you really see the load is also not too much on the system. I think we did a good job making the system. It's looking quite okay. Okay. So it looks quite okay in terms of performance and in terms of how the errors, or what we were expecting in terms of errors. So it's been quite satisfactory. So let's see. Okay. So again, not much of a yeah. I think we should reduce the looping a bit. Let's see. Yeah, okay, cool. So yeah, average time has been 10 seconds. The throughput has certainly dropped to 98. So let's write it down. So 98.9 is the throughput. This one was 2100. CPU still not much, and yeah, it's gone to 10 seconds, but fantastically 0 errors. So now I'm going to push it to 200 each and see if our system is able to handle that or not. Oops. So that will be some of, yeah. So expected result will be the average time should increase, errors should not happen. CPU might not be used too much, but let's see. So I'm gonna change into the file. So let's really load it ahead. 2000 each, yeah. Okay, here we go. Yeah, okay, 320, CPU's 33%. Yeah, looks like this is 455. Yeah, CPU almost went to 33%. And yeah, now it's gone down. So maximum peak CPU where we pushed it out was 33%, and this one is already gone to 420. So let's see how the error part comes in over here. So let's see. Yeah. Yeah, okay. Wow, fantastic. Still no errors reported, and but the throughput has drastically dropped, so as you can see that it's not even catching up to 2153. So, and the average time and the maximum time has also gone up, so it's already, we are hitting the barrier of 53 seconds on average, 24. So yeah, I think this is the point where the system might be looking into throwing some errors. Let's yes, so at this point we have started getting the errors. So 2000 times 3, that means 6000 requests concurrently coming in, and we have errors coming ahead. Still CPU is not used much, threads are not used much, but it's just that the total system is not able to handle. And as you would see that we have errors cropping in. So over here, in fact, 61 errors have happened. Yeah, so that's I think this is the collapse point. So the TPS also has, throughput has also dropped down to 2. So yeah, system is not able to handle the load of 6000 concurrent requests coming in. Yeah, so yeah, 6300. Yeah, so that's also gone in a big way. CPU is also 25% now. I think yeah, that's where things are looking choked up. Yeah, 35% already, almost 700, 8000, sorry, 8000 threads, 8113 threads. Yeah, so if you look at it, yeah, okay, that's a huge number of errors which have started coming in over here. TPS looks a bit better, but again, it's kind of collapsed. So I think that's the break point where we can't push the system. Yeah, let's just wait for it to finish and give us the final stats. Yeah, okay, so in the meanwhile we can, yeah, okay, too many errors cropping in, so I think the system is not able to handle. So sorry, these two are for the above ones. Yeah. And went up to 35%. It's already 8,100 which came in, as you would see. Yeah, so now it's dropping, but the throughput is already quite poor. So let's look at the summary part. Yeah, so 8,000, I think. Yeah, errors are on average a lot now. Yeah, so that's the collapse point we have figured out, which is I would say quite decent. Yeah, okay, so the TPS we got was 88, and then we have got 6.19% error. So let's write it down. So we have got 6.19% error, and yeah, the TPS was 88, and yeah, the average time was 19.2 seconds, which is again, I think, the kind of part where it really fails. Okay, so as you would see is that the breaking point is almost somewhere near between 2000 to 1000, but I think 1000 itself is very, very high. The performance in terms of the system which can handle with single, not even HA, it's quite decent and nice. So thank you so much. We truly appreciate kind of walking through this whole long exhaustive stress testing. Yeah, thanks.